Hi everyone, I am Abubakar Siddiq. I'm a technical evangelism program manager at GitLab, and I'll be sharing with you why we are choosing Cloud Native Buildpacks at GitLab. Yeah, first I'll be the first things I'll go through is just a brief introduction into what Buildpack is and why are we using Buildpacks, how we use Buildpacks at GitLab, and also a short demo of how we use Buildpacks with our GitLab Auto DevOps. First, what is Buildpacks? Buildpacks are basically used to convert code to compiled code or any generated asset that can be used to automatically detect what the code is, in which language it's written, and get the necessary dependencies and binaries required to compile it to the compiled code. And this was first initiated by Heroku. This is an example of a flow of how it's done. Once a developer pushes their code to probably a code hosting platform or anywhere, and the CI picks it up, it checks first using a build pack to see, okay, what language is this written? If it's Ruby or it sees a gem file, it automatically builds the application using the specified binaries and images that have been compiled and used to run the application. Then it deploys it to the right place for it to run. Then here's an example here of what I just described. It first checks, is there a gem file? Okay, then it's definitely Ruby. Then every dependency needed based on the gem file is used to compile the application. Now, and the basic logic it uses based on the Heroku build pack for Ruby is it checks basically, if as we can see here, based on the detect file that is included in Heroku's build pack for Ruby. Can it find a gem file? If yes, then it's definitely Ruby. If not, it's not. Basically, almost every Ruby application has a gem file. Now, as Buildpack has evolved, everyone saw the benefit in being able to ease the work of the developer in detecting the language they've used to build the applications and using the necessary dependency to build them in CI and deploy. Pivotal created their own Cloud Foundry build packs, and Heroku had theirs. And this led to, because there's most of it is proprietary, you can only use it on their platform. The rest of us are basically left with Heroquish. Heroquish is an open source version, which largely depends on Heroku build packs. So basically, what happens is it has already taken all the necessary runtime and of Heroku, emulates them, and uses Heroku supported build packs to now build the application and run. It comes in a binary file, or you can deploy it using Docker. Now, then came in Cloud Native Buildpacks. Pivotal and Heroku decided to bring all the power and experience they've gathered together from the running Cloud Foundry build packs and also running Heroku build packs for quite a long time, bringing all the learnings and the failings. Then decided to create an open source Cloud Native build packs, which will make it much more easier for almost everyone who wants to use build packs. And gladly, it's under the CNCF. It's being overseen by the CNCF, which makes it much more easier, maintainable, and out there for everyone to use. Now, and some of the features of build packs is the final output that is generated is in Open Container Initiative image format, which is supported by almost every of security is when images are created, there are possibilities of privilege escalations due to the possibility of having privileged containers. Now, and also we have faster builds and image layer rebasing. What this means is when the build packs has majorly two things that it uses to build the images. First is the builder, which contains all the necessary runtimes and routines that is necessary to build the application. Then we have the pack CLI, which is used to pack the applications. So now, when an application has been built with the necessary build images and run images that are necessary for it, and subsequently down the line, there's an update in the application code, an image, instead of having to build the whole binary again, the layer that contains the application code can simply just be changed with a new version. So build packs, Cloud Native Buildpacks come with a command rebase that you can use to change the tag of the image layer, so it's simply swapped for a newer version. So this makes for faster build and allows the CI runtime to run much more faster because it doesn't have to build every individual layer of the cluster again, just the layer that has changed. Now, Cloud Native Buildpacks comes with two major, like I mentioned earlier, comes with two major components. We have the pack, which is the CLI for building the application, and we have the builder, which is the image that contains everything necessary to build your applications. Now, Cloud Native Buildpacks has a life cycle. First thing when a code is deployed to probably by the CI platform or any way a platform is being used, the first step for a builder is to detect what type of application is this. Based on the example of Heroku that we saw earlier, it checks if there's a gem file. If there is, this is definitely a Ruby application. Then it analyzes the code to determine what are the necessary dependencies that this application needs. Okay, then it pulls all of them in and gets everything necessary, all necessary dependencies for the application to be built. Then it builds everything, and exports it into an OCI image so that it can be deployed anywhere and used on any platform. Now, at GitLab, one of the major features that we have is our auto DevOps, which allows you to just push your code without necessarily declaring a CI file or setting up the configuration of how your CI should run. And GitLab will automatically detect, okay, what's the programming language this is in? What are the dependencies it requires? What are the tests that has been written for it to run? Then it runs all of them, runs all of the testing, deploys to staging for you if you have staging already configured, deploys to production, and even do all the necessary performance tests and runnings that you want to do. So for example, in the image we have here, we can see that it has a build job, it has test job to check code quality, do SAST security analysis testing, and so on and so forth, and moves to staging, production, and performance. Basically, it allows you, just from pushing your code without doing anything else, GitLab takes charge of the whole thing down straight to production and running your performance. Now, but to do this, GitLab needs build packs. Now, first, we need to be able to detect the language that is being used, and we currently use Heroquish for that. Once we've tested, we need to be able to build the application. We still use Heroquish for that also. Now, and for testing, we use Herokuish build pack tests to test all the different components after we've built, okay, to make sure everything is fine before we proceed. We use the same image to deploy to staging and so on. So, but why are we switching to Cloud Native Buildpacks? The main reason is because, one, we need, when using auto DevOps and because most of this happens over the internet, the amount of data that is consumed in building, rebuilding, pulling images and so on is enormous, and image sizes tend to grow as along the line in the CI pipeline. So one of the reasons that we are switching to Cloud Native Buildpacks is to make the image sizes lesser with image rebase, like I mentioned earlier. Then faster builds. Once the rebase can be done, it's easier for us to run builds much more faster. And the fact that we're using Heroquish, which has an onshore feature, there are already talks about archiving it soon. So it's one of the reasons that why we need to move forward in using a newer and more stable platform. And also, we are a company that is largely supportive of the cloud native ecosystem, and the fact that it's a TNCF project is also one of the main reasons why we are switching to Cloud Native Buildpacks. In the link below, you can see the different stages of our auto DevOps lifecycle and why Cloud Native Buildpacks is important to us at the moment. Now, then, how will Cloud Native Buildpacks work this time? Ordinarily, in the auto DevOps example I shared earlier, by default, it simply just uses Heroquish, and it builds everything without you having to specify your GitLab.CI YAML file. That is the file we use to specify how CI should run and how the deployment should be done. But to enable it at the moment, it's opt-in. Cloud Native Buildpacks, we are still improving it and building it more. But at the moment, if anyone wants to use it, they will have to opt in by creating a custom GitLab CI file and specifying that they are still using the auto DevOps templates that we use for them automatically, but with just some modifications. And those modifications is by specifying that, okay, for the build stage of the CI pipeline, you want to use the Cloud Native Buildpacks. So an environment variable has to be declared by saying auto DevOps build image CNB enabled, specifying it as one, and also specifying the image it will use as shown on my slide here. Now, once you've specified that, during the build stage, the CI job will not use Heroquish. It will use the Cloud Native Buildpacks to build everything and move it along the stage. Now, but there's just one drawback, which is one of the advantages of using Heroquish, that it has buildpack tests, which we use extensively in our auto test job. And Cloud Native Buildpacks only currently comes with build and rebase commands. So at the moment, we are, because the testing stage is very important and a stage that we are definitely still sticking with and we will still be using, we are still maintaining using Heroquish for the test job, but we are already making strides and trying to collaborate with the Cloud Native Buildpacks project to create an RFP and also contribute, if possible, contribute the test stage to Cloud Native Buildpacks. So because this is important and we feel other members of the community also need this and they will benefit from this as the project grows. Now, this is basically how we currently use Buildpacks for our auto DevOps jobs. So I'll be showing you a demo of an example of how one can opt in and use Cloud Native Buildpacks. Now, first, I've already prepared the demo to save time, and I'll be sharing you screenshots of some of the results from the demo. In the image here, you can see that I have a sample Ruby project that has a rake file and a gem file. So yeah, it's just included. The GitLab CI file was included subsequently after enabling CNAB, but by default, it doesn't come with a GitLab CI file. Now, the next thing is when I deploy this at first with Auto DevOps enabled in CI, it's normally enabled by default, except if your organization disables it by default. Now, Auto DevOps then sees the project, sees a gem file, uses Herokuish to detect the programming language to be Ruby, and it starts the build job, creates jobs for the test stage, production, and the performance stage. Now, on the second slide, I'll be showing you in the CI log. As you can see here in the first red box, it clones the Glider Labs Heroquish image, and it uses that in the second box to now run Heroquish buildback build. This is by default what it does when not using Cloud Native Buildpacks. Now, the next thing here is in the GitLab CI file, we created a custom GitLab CI file and specified that, okay, we are still using the Auto DevOps template, but we want to enable Cloud Native Buildpacks by specifying the environment variable, setting it to 1, and also specifying the image to be used. Once this is done, in the build stage, instead of using Heroquish, this time it switches to building with the Cloud Native Buildpacks. Now it pulls the image. Once it does that, then it uses the Heroku open source build packs for Cloud Native build packs, as you can see online, the 251 here. Then it uses that and downloads the open source version of the Heroku pack also to detect the language that the project is used in, which is here. You can see here it's Ruby. It detects the prop file. Then it analyzes the code for all the necessary dependencies and information that it needs, and it proceeds to compiling. So basically, GitLab as a company uses Auto DevOps or has Auto DevOps as a feature for our customers and for our users to be able to build straight from idea, straight from idea to production without little to no intervention, giving developers more productivity. But we can only achieve this with build packs. And with from the beginning, Heroquish was the only option for users who wants to use it outside of Cloud Foundry and Heroku. And with the Cloud Native build packs, we are able to build much more faster and more efficient images for deployment. And given that Heroquish is probably going to be archived soon, Cloud Native Buildpacks is the feature and the only option that whoever wants to use Buildpacks has. Thank you very much for your time. Hi, everyone. Thank you very much for joining this session. And yeah, I'll be answering a few questions that have been coming in. I think one of the major ones that have been asked is how does Cloud Native Buildpacks relates to Cloud Native Application Buildpacks? Yeah, they are two different projects, and off the top of my head, I've not really used Cloud Native Application Buildpacks much, but based on the things I've read previously, Cloud Native Application Buildpack seems to be like a standard packaging format for distributing Cloud Native application in the cloud. Yeah, off the top of my head, but there are two different projects. Also, a question was asked the other time, how do these build packs relate to Pivotal Cloud Foundry build packs? Like I said in the presentation, there was Heroku build packs separately, then there was the Pivotal build packs separately, most of which were proprietary. Cloud Native Buildpacks was an effort that came after both companies decided to standardize and open source the Buildpacks. Also, there is how does CNAB compare with Red Hat's source to image used in OpenShift? I've not really used source to image, so I won't be able to give a honest comparison of it with Cloud Native Buildpacks. Yeah, okay, I think that's most of the questions that have been posted. Okay, I have more here. is it possible to disable or override specific job in the build pack using GitLab CI? Yeah, I just want to add more information about our auto DevOps. It is highly customizable. You can even go as far as, because we are the auto DevOps CI files are more or less templates that we've created to be language agnostic and work with almost any language. So you can customize it as much as you want, change the images that are being used. You can decide to package your own images. You can decide to even decide to not use them, just pick a couple of things in them and use your own pack CLI directly in your CI job. How does an ops team should use build packs to patch base OS image? So I think I don't have much information about this, but I can definitely share more in the Slack channel. But I think majorly, as at now, the two major functionality that build pack has, it allows you to build and it allows you to rebase. So I think probably rebasing might be, me guessing off the top of my head, rebasing might be an answer to this, but I'll look this up and provide more answers to it in the Slack channel. Yeah, the Slack channel for this is case studies. Yeah, KubeCon case studies. But you can also drop in to ask more questions about auto DevOps, and most of our engineers are on the GitLab channel, so you can ask more questions there. So any more questions from anyone? While questions come in, I think I still have some time. Yeah, basically, since the recording of the call, we've added more new features to the way we use. If you noticed in the slide earlier, you had to specify the image to use for build packs, but now it has been baked into the auto DevOps templates. You don't need to specifically specify an image to use when you want to use Cloud Native Buildpacks. And previously, after the recording, with discussions among some people in the industry, most have asked, okay, why do you still want to stick to Heroquish and so on, when there are probably other ways tests can be achieved with Cloud Native Buildpacks? And the major reason why we are still sticking with Heroquish for now is because we don't want anything to be custom in the templates that we provide as a company. We want it to be language agnostic. We want simply, when you are using auto DevOps, to just push your code and it detects and it builds without any customization. That is why we are still sticking with Herokuish test functionality, because it's dependent on Heroku's test API. So we are using that mainly because it has support for a lot of languages already. Okay, a question just came in. Is there a possibility to create own build pack and share with the community? Of course, you can create as much as you want the builders and share, and within your application, you can always specify a builder to use. You can check my slide subsequently. You will notice in this slide, we automatically used a builder from Heroku. So you can decide to have a builder, create your own builder for a particular language, or for anyone that you think it's necessary for the community to benefit from, and share it with the community. So I still have like 2 minutes, but if we are unable to answer all the questions here, just like I said earlier, you can ask more questions in the case studies track channel, and also you can ask more questions about other things we do around auto DevOps, especially with other stage, because this is focused more on the build and test stage of deployment. So we are there to answer most of the questions you have around that. And also our engineers who are working on how we use Cloud Native Buildpacks will also be on the Slack, so you can ask as much questions as you want there. Okay, yeah, I think there are no more questions here. Thank you very much for joining this session. Do have a lovely day and see you on Slack.